Good morning. So this is 419 Computable General Equilibrium Models. And today we're going to continue with a production model. Let me share my whiteboard. Where is that? Okay. So, all right. So today, again, this is the model in chapter 3 of your textbook. Okay. And first of all, before diving into the mathematical details, let me give you an overview of this model. All right. So in this model, on one side, we will have households. Okay. So typically, they're gonna be indexed in this way. All right. So these households will have some endowments. Okay. These endowments would be like land, labor, capital, and stuff like this. Okay. And they're going to be having preferences for consumption goods, and if they use these primary factors for themselves, preferences for these as well. Okay, so you might imagine that they have preferences for consumption goods or leisure, right? And things like that. On this side, we will have firms. Okay, so firms will be indexed by I and J. And in this economy, there will be n different firms, and each of these firms will produce a different good. Okay. Now again, as we've seen in last week, in each sector, there will be one firm, but that firm will be competitive. All right. So once again, we're gonna assume that there is perfect competition in this model. All right. But for simplicity, we assume that each sector will produce only one good. Okay. So then, as you see, there are two different goods in the economy. One is primary factors, right? So these are non-produced. Okay, these are given. And then we have produced goods. Okay. Now, the important thing is that these produced goods are going to be used by intermediate inputs as well. Okay. So some part of this will go to consumption demand by households. Okay. Another part will be intermediate input demand by firms. Okay. So my typical example for such an economy is a burger house. Okay. So imagine that you want to open, you are an entrepreneur and you want to open a burger house, let's say in Ankara or Istanbul or in Mersin or Los Angeles. All right. So you want to open this burger house to sell burgers, right? Now, what do you need? First, you need the restaurant itself, right? So for the restaurant, you need, first of all, land. Then you need building, you need vehicles, and you need labor, right? So first, you're gonna purchase the land or purchase the land or rent the land. Then you're gonna build your restaurant itself. Then you're gonna put into you're gonna hire some managers, some cooks, and some waiters and waitresses, right? So essentially, before you start production, you're gonna hire these primary factors. Okay. So you may imagine first, if this is your, let's say, burger house, all right? Suppose that this is your burger house. Robin's Burgers, okay? So this is your burger house, okay? For this, you need land, labor, capital, and other stuff, all right? Now, once you have the burger house, then you need intermediate inputs. What are these? Well, you need what? You need bread, you need meat, you need onions, you need mustard, you need ketchup, right? What else? Tomatoes, and things like that, right? Now, to produce the product, to produce burgers, you need these inputs as well. And as you see, these are produced goods purchased from other firms, okay? Now, once you have both, then you will have the burgers, okay? So that's an idea. And of course, if you think about this carefully, there is, of course, another production of bread, right? So this bread producer will also have his or her shop, okay? So there will be an oven there, right? So there's a land, there's a building. Then, once again, this firm would need land, labor, and capital, okay? But in the meantime, this firm also needs things such as flour, salt, water, and other stuff to produce breads, okay? So that's the idea. The idea is that there would be many firms. All of these firms, you may imagine such a circular system actually. Now here there are capital, land, labor, and other stuff. Okay, and each of these circles is a firm producing a specific commodity. Now they have demand for these resources. Okay, these resources flow to these firms. And also the production of these firms will also be demanded by other firms in the economy. So there's actually a network, right? Different firms are demanding different firms' products as intermediate goods. Okay, and sometimes, this is also important, some firms will also be using their own production, okay, as intermediate input. For instance, in agriculture, if you produce some fresh fruits, then the seeds of these fruits will become part of your input set. Okay. So that's the type of economy that we're going to study now. Okay. So any questions before I start? Okay. Now, once again, we have, let me check my notes. So again, there are many households, right? There are many households. And each of these households have consumption, before consumption, of course, they have utility functions, okay? So these are utility functions. plus endowments. Now, for endowments, we are talking about, of course, primary factors such as land, labor, and capital, right? So in this economy, there will be N. This is the number of produced goods, okay? And K is the number of primary factors. So in our earlier example, primary factors are land, labor, capital, etc. And this is bread, onions, meat, ketchup, etc. Okay, so these are the numbers. H households, N produced goods, and K primary factors, right? Now, once again, of course, we want to have a price vector. So price vector will be defined in this way for produced goods. And we will also have factor prices. Okay, and factor prices will be denoted by omegas. Okay, so these are the prices. P is the prices of products, the produced goods, and omega, or if you like, W, is the price of primary factors. Okay, so for the households, of course, we're going to look at the utility problem, right? So we're going to look at a problem like this. So there is this household which maximizes utility obtained from two things. First, there's consumption vector, and then there is this endowment of primary factors. All right. So here, the budget constraint looks like this. So from I to N, we have PI, CH, CIH, right? This is the consumption expenditure. Then we have, I'm going to explain it in a moment. We have omega K X I K, sorry, X chi H, sorry, X K H, right? So this is K, this is H. Now this must be equal to what? This must be equal to the total income from endowments. All right, so this is W K E K H. Right? Now what is happening here? In this problem, the consumer may use some of the primary factors, for his or her own benefit. What's the typical example here? Consumption and leisure. Let's look at a very simple example now. Remember our toy model? There was this utility function, right? ln C plus L, right? Remember, C is consumption, and L is leisure. Now, the budget constraint would look like this, right? Remember, PC equals W times H. H would be the labor supply. Okay, H is labor supply. But then we also had this time constraint. Okay, now if you put this into that, you're going to have PC equals W times 1 minus L, right? And if you rewrite this in this way, PC equals, so PC plus WL equals W times 1. You see? Now you have the utility function. In the utility function, there is both the consumption and the resource that the consumer uses by himself or herself. And then there is the budget constraint. In the budget constraint, we realize that the price of leisure is, of course, the wage, right? Now my endowment is 1, right? This is my endowment, which is equal to 1. This is the resource of time that I use by myself. And this is the price that I have to pay because in the market, I obtain the wage, okay? I obtain the wage W if I work full-time, or I would prefer to work less than full-time and keep L as leisure for my own benefit, okay? So here, we wrote this problem in a highly general way, okay? There could be, of course, now many goods, right? For each good, I'm making this consumption expenditure. Okay, so this is the consumption expenditure you are making for each of the consumption goods. This is your total income because you are selling your endowment in the market at this market price. Okay, you have land, you have labor, you have capital. You are selling each of these in these factor markets, right? You go to the bank, you deposit your savings. That earns you that gives you a capital income. You have this land, you rent this land to farmers, let's say, you earn some land rent, and you work as a worker and you obtain some wage income. But sometimes you may want to keep some portion of these resources to your own use, okay? It doesn't have to be just leisure. Imagine that you have this land and you're gonna rent this land to some producers out there, but you may keep some portion of this land to yourself for your own enjoyment. Maybe you would like to have weekend picnics with your family and friends. You see my point? So then you have some foregone income, right? Foregone income is represented here. Okay. So that's it. That's the type. And if you solve this problem, of course, you're gonna find consumption demands, right? You're gonna have each household will have a demand function for produced goods and a supply function for primary inputs, right? So this is the demand for, this is consumption demand. And this is factor supply. Now, factor supply, of course, will satisfy what? There is EH, then there is XHPW. Okay? Of course, these are coming from, you know, these are optimal choices, right? You may put stars to understand that these are optimal choices. Okay? Now, of course, sometimes for some K, you may have this. EH equals XH star. Sorry, you might have, sorry, not true. You might have, for some goods, XHK star PW equals 0, okay? In that case, supply of this factor would be equal to the endowment, right? In such a case, we call this inelastic supply. Right? It is inelastic because it doesn't respond to prices. Right? Supply is just equal to total endowment. So when does this occur? When the resource is not preferred to be used by the consumer himself or herself. Right? So there's that resource, okay. But I do not obtain utility by not selling it. So it is it is not in my utility function, then I sell all of my resource. Okay, so this is my entire endowment, right? This is my entire endowment, and I sell all of it to the market. I supply all of it. In such a case, supply is not, does not depend on factor prices. Since it does not depend on factor prices, we call it inelastic. Okay. So that's the household part. So again, if you want to summarize it, these households have primary resources. These are land, labor, capital, and other stuff. These are not produced, right? And then these consumers will also have some preferences over produced goods, such as burgers and bread and water and all this stuff. Okay? So they solve a utility maximization problem. Their income originates from their endowments. These endowments are, again, factors, primary factors. So they sell these primary factors in factor markets. Here, firms are buyers, obviously. And at those factor prices, there is, of course, an income originating from these. This total income is now distributed among consumption goods and factor demands. So some factors, again, such as leisure, for instance. So if there is a time resource, time could be spent on two things, either to leisure or to labor supply. And if consumers have preferences over leisure, if they would like to have some free time other than working, then they pay a price, and that price again is the market price for time, basically wage. Okay. So once you solve this problem, you express consumption demand as function of prices and factor supplies again as function of prices. Okay. So do you have any questions about the household part? Household part is relatively simpler because this is the typical consumer problem. It is static. Consumer knows all the prices. He or she knows all the endowments. Utility function is also known, so they solve this rather boring utility maximization problem. Any questions?
No.
All right. Okay. Yes, it is pretty straightforward. Now let me continue with the firm problem. Okay. So now for the firms, firms, as you realize, firms will have two-step problem, right? So these are the firms. One important assumption, each good is produced by only one firm, but this firm is the price taker. Okay? So we're going to use the same trick that we used last week. We're going to assume that there is still a competitive market, all right? Even if this firm is just the only firm that produces it, it is one of many firms, you may imagine, okay? Let me be much more specific here. Let's say there are actually many firms that produce good I, but they are identical and their mass is just equal to 1, okay, as in last week. So we basically take a shortcut here and we say production is done by only one firm, but this unique firm is still a price taker, so we can still understand the entire thing as a competitive equilibrium. Okay. So what do we have? Well, we have first the production function for the the burger house. Okay, XKJ. So what is that? There's actually, so the production function doesn't have to be the same. So look at this. So on the left-hand side, you see the burger, the capacity, right? So if I use, let's say, one building, okay, 2 vehicles, 1 manager, 10 waiter or waitresses, okay, etc. And if I have, let's say, like 200 meters squares of land, etc. Right? So all of these will give you what? A production capacity. You may imagine this as your, producing your capacity, right? Right now, this is the first step. Now you have the burger house. Okay. That's the first part. So this is again a production function. You need, let's say, with 1 building, 2 vehicles, 200 square meters of land, 1 manager, and 10 waiter and waitresses. You are now ready to produce burgers. So this creates a capacity for you. Okay. Next, of course, we're gonna have the other part, how to produce it, right? There's one assumption here. Let me be specific about this. This f function will exhibit constant returns to scale. Okay, CRS. So if for instance, it's Cobb-Douglas. Cobb-Douglas is just one example, right? If you have K alpha, L1 minus alpha, if you increase both inputs by the same factor, right, then your production would be like this. Okay, constant returns to scale. So of course you may have many different inputs, and your production function could still be another one would be CES, right? If you write the CES production function, let's say alpha k to the row 1 minus alpha L to the row to the power of 1 over rho, right? Now still you have CRS. Or your function could be linear, right? So there are many examples. So you can check your mathematical economics or microeconomics notes for that. Well, okay, we have less than a minute, so time is around 9:40. Let's meet at 9:55. All right. I lost track of time. Let's meet at 9:55, my friends. All right.
Tamam hocam.
Okay. Bye bye.